right, 1.2a, we are going to use the unit circle. So I would suggest making sure you have your unit circle out. Again, you can use the smaller one on this side, or if you have your bigger one ready for you. But just a quick reminder, we talked about how we're using the point xy. And we talked about sine being your y value, cosine is your x value, and tangent is your y over x value. Okay? There are also 3 more trig functions that we need to talk about, and that is cosecant, secant, and cotangent. The cosecant is the reciprocal of sine. The secant is the reciprocal of cosine, and the cotangent is the reciprocal of the tangent. Now, the way I remember is that S and S do not match. So you have to have one S and one C, or one C and one S. I don't know if that helps you, but it helps me remember which is what. So, if in our first example, it says to find the point xy, or on the unit circle, for the following values. So if theta is pi over 2, 5 pi over 3, 5 pi over 4, and negative 5 pi over 4. So all of these are our values for theta. If all we're doing is finding the xy point, then we'll take out our unit circle, and for half of pi, it's right here, so our value for x and y is 0, 1. 5 pi over 3, I have to find 5 pi over 3 first, and that is down here, and the x and y value at 5 pi over 3 is 1/2 negative square root of 3 over 2. Take a second and find 5 pi over 4, and what is the x and y value for 5 pi over 4? Hopefully you found it down here in the third quadrant, and the x value and the y value are both negative square root 2 over 2. Now, if 5 pi over 4 is down here at 225 degrees, where is negative 5 pi over 4? And that would be going the opposite direction, the same distance, and that would land us at a coterminal angle, or I'm sorry, at the 3 pi over 4, which is at negative square root 2 over 2, positive square root 2 over 2. So once you understand how to find those values, it's going to make it easier now finding the 6 trig functions. So the first question that we want to look at today is find the 6 trig functions for when theta, now it can also be written like this, is pi over 6. So the first thing I need to do is I need to find pi over 6 on my unit circle and write down my x value and my y value. So it is equal to the square root of 3 over 2, 1/2. Again, remember this is your x and this is your y. Now, the 6 trig functions, we know that sine is the same as the y value, so the sine of pi over 6 is equal to 1/2. Cosine is the x value, so cosine at pi over 6 is equal to the square root of 3 over 2. The tangent is the same as y over x. So this is a little bit more complicated now because we have a fraction within a fraction. So y is 1/2 over x, which is the square root 3 over 2. We need to do a little math with this. I find complex fractions are much easier to rewrite it the old-fashioned way. 1/2 divided by the square root 3 over 2. When you divide fractions, you keep the first, change division to multiplication, and flip the second to the reciprocal. 1 times 2 is 2. 2 times the square root of 3 is 2 square roots of 3. We cannot combine radicals with numbers. 2 divided by 2 cancels to 1. Now, we have to rationalize this. We cannot keep the square root of 3 on the bottom of a fraction. So to rationalize it, even though this is our answer, we have to multiply the top and the bottom by the square root of 3. And now 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, which equals 3. That is the tangent. The tangent you will find is always the hardest. All right, let's go to the other 3 trig functions. We know that the cosecant is the reciprocal of sine. So if sine is 1 over 2, the cosecant then is 2, or 2 over 1. The secant is the reciprocal of cosine, and when we flip this, we get 2 over the square root of 3. Again, we have to rationalize. We cannot leave the square root of 3 on the bottom, so I'm going to multiply the top and bottom by the square root of 3. 2 times the square root of 3 is 2 square roots of 3, because I cannot combine numbers with radicals. However, this gives me the square root of 9, which we know is 3. I cannot cancel this 3 with this 3 because this is a number and this is a radical. Now, the cotangent is the reciprocal. Now, let me show you a trick here. If you've already had to rationalize, if I flip this, I'm going to have to rationalize again. So go back to the part before you rationalize 1 over the square root of 3, and now flip that to the square root of 3 over 1. That would be the quickest and the easiest way to do that. All right, on your own, see how far you can get by finding the 6 trig functions of 7 pi over 6. The first step that I need to do is find 7 pi over 6 on my unit circle. It is the negative square root 3 over 2, negative 1/2. So this is my x and this is my y. Sine, we know, is the y value, so the sine is negative 1/2. Cosine is the x value, and that is negative square root 3 over 2. The tangent is y over x, and so if I take y over x, I'm back to a complex fraction. So when I rewrite it out as negative 1/2 divided by negative square root 3 over 2, keep the first, change this to multiplication, and flip this over, I end up with a negative times a negative, which is positive 2 over 2 square roots of 3. 2 divided by 2 is 1. However, I need to rationalize this by multiplying both the top and the bottom by the square root of 3. 1 times the square root of 3 is the square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is a positive 3. Notice my tangent is positive because a negative divided by negative is positive. All right, cosecant is the reciprocal of sine, so we have a negative 2. The secant is the reciprocal of cosine, and we have a negative 2 over the square root of 3, which again, I need to rationalize, and when I do that, I end up with negative 2 square roots of 3 over 3. The cotangent then is taking and either going through this whole long process again, or if you can't remember, flip the reciprocal. However, you have to rationalize, and when I do that, I end up with 3 square roots of 3 over 3, and I can divide these numbers with each other, and I get just the square root of 3, which, if you remember, before I rationalized, I could have flipped right away and saved some work. Now I want to talk about finding the 6 trig functions when theta is half of pi. Now, what's different about this one? Well, first of all, half of pi has the value of 0, 1. So x is 0, y is 1. So the sign of half of pi is my y value. The cosine of half of pi is my x value. The tangent is y over x. Y over x. Now, if you do this on your calculator, you'll get an error. Do you remember learning that if a number, and this is how I remember it, a number over 0 spells no. You cannot do it. It is undefined. I cannot eat 1 cupcake if 0 cupcakes are sitting there at the table. All right, the cosecant is the reciprocal of 1. Well, when I flip 1 over 1, it's still 1. The secant is the reciprocal of 0, or 0 over 1. When I flip that, I get 1 over 0, and I'm back to undefined. The tangent, or the cotangent, flipped. Now, instead of 1 over 0, is 0 over 1, and 0 divided by 1 is 0. I can choose to have 0 cupcakes out of the 1 on the table. I just didn't eat it. So there will be times when you have to remember how to do undefined also.